Hey guys, Mr. T here, just doing a quick video on exercise 2F. The questions you're asked to do on the timeline. Questions 1, ACEG, 2, ADGJM, 3, ADGJ, and 4, ADGJ. And this is on factorizing quadratic trinomials, but the better name for it would be sum and product rule, which is the reverse of FOIL. So that rule was, if you've got a quadratic in this form, 3 terms, x squared plus px plus q, that factorizes to x plus a, bracket x plus b. Where did these a's and b's come from? Well, if two numbers a and b are multiplied together and they produce q, and if those same two a and b add together to produce p, then that factorization applies, and multiplication means product. Adding sum means addition. Okay, so the first part of this exercise, literally, it doesn't ask you to do the sum and product rule. It just gets you to practice deciding what two numbers have a certain product and a certain sum. So the product of 12, well, what are the factors of 12? I could times 1 and 12. I could times 2 and 6. I could times 3 and 4. The next one is 4 and 3, but I've already got 3 and 4, so I just stop there. So I have the factors of 12 here, but I need two numbers which also have a sum of 7. 1 plus 12 is only going to get you 13, or if I take it, 11 or something. So the only possible numbers I can get with 1 and 12 is 13 or 11. 2 and 6 I can get 8 or 4, but 3 and 4, 3 plus 4 is 7. So find two numbers which have product 12 and sum 7, 3 and 4. Product 16, so the factors of 16, 1 and 16, 2 and 8, 4 and 4. The next one is going to be 8 and 2, so I stop there. Sum of 10, 1 and 16 is not going to give me a sum of 10, but 2 and 8 will give me a sum of 10. Product negative 36 and sum of 9. Now, ignore the negative for now. We'll just do the product of 36. 1 and 36 gets you 36. 2 and 18. 3 and 12. 4 and 9. 6 and 6. And the next one up is going to be 9 and 4. So stop there. How do I get a sum of 9? 1 and 36 will never get me 9. 2 and 18, best I could do would be 20 and 16. 3 and 12, there's a way I could do that. Because I want positive 9 there, if I did negative 3 plus 12, I would get positive 9. So that also fixes the negative here, because negative 3 times by 12 is going to be negative 36, and negative 3 plus 12 is going to be positive 9. Product of negative 12, so be careful of negative again, but the sum is negative 4. Ignore the negative product for now. What are the factors of 12? 1 and 12, 2 and 6, 3 and 4. 4 and 3 is the next one, so leave it. Is there a way that I can get 4 with 1 and 12? No, I can get 11 and 13. Is there a way I can get negative 4 with 2 and 6? Yes, there is. Because if I had positive 2 and I took 6, I would have negative 4. So 2 and negative 6, and also that fixes the negative sign here, because 2 times by negative 6 is going to be negative 12. So that is practicing finding a pair of numbers that have a certain product and also a certain sum. So let's practice fully factorizing using the sum and product law. So based on the lesson that you've been taught, and also some of this little thing here, this is x squared plus px plus q. Work out what the factors of q are. What are the numbers I times together to get 2, 1 and 2? Is there a way that I can add them or subtract them together to get 3? Yeah, 1 plus 2. So my a is 1, my b is 2. So this factorizes to x plus 1, which is a, and x plus 2, which is b. Same thing again. What are the factors of 10? Well, negative 10, but ignore the negative for now. 1 and 10. 2 and 5, that's it. Is there any way that I could get 3 using 1 and 10? No. Is there a way that I could get positive 3 with 2 and 5? Yes. If I had negative 2 and I added 5 to it, I would get positive 3. And also, negative 2 times by 5 is negative 10. So this factorizes to x take 2, x plus 5. Because we decided A was negative 2 and B was positive 5, just like the rule shows here. Next, factors of 49, 1 and 49. 2 doesn't go into it. 3 doesn't go into it. 4, 7 and 7 goes into it is the next. Is there any way I can get negative 14 from 1 and 49? No, but I could do it with 7 and 7, because if I had negative 7 plus another negative 7, negative 7 take 7 is going to be negative 14. So that's my A, that's my B. So this is going to be x take 7, x take 7. And if you notice that you're timesing the same thing by itself, it's x take 7 squared. This is also a perfect squares, if you notice as well, because this is a square number, this is a square number. The square root of this is going to be x. Square root of this is 7. X times by 7 is 7x. Times by 2 is 14x. So you could have done this with perfect squares as well, but here I showed you how to do it with sum and product rule. Next one, factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Next one's going to be 6 and 4. So that's it. I cannot get negative 11 using 1 and 24. I can't do it with 2 and 12, but I can do it with 3 and 8. It'll be negative 3, take 8. So that's my A and that's my B. So this factorizes to x take 3 and x take 8. Last one of this group. Factors are 56, 1 and 56, 2 and 28. Ooh, this is testing my times tables. Does 3 go into 56? 56 divided by 3? No. 56 divided by 4? Yes. So no 3. 4 and 14. Uh, 56 divided by 6, no. 56 divided by 7. 7 times by 8 gives you 56. And the next one would be 8 times by 7, so I stop there. Is there any way that I can get negative 1? Because be careful, there is a number in front of it, it's negative 1. It can't be 0, because if the number in front of x was 0, this wouldn't exist. So is there any way that I could get negative 1 with 1 and 56? No. 2 and 28? No. 4 and 14? No. But 7 and 8? Yes. I need negative 1, so I'd be 7, negative 8. 7 take 8 is going to be negative 1, so that's my A and B. So this factorizes to x plus 7, x take 8. Fully factorized by removing a common factor. So you're being told here that there's a common factor across all of them. You should always check anyway, but 2 goes into all of these. So remove 2 as a common factor first. Remove the common factor outside a set of brackets. What do I times 2 by to get 2x squared? I would times it by x squared. What do I times 2 by to get 10x? 5x. What do I times 2 by to get 8? 4. So now we try to factorize this with sum and product rule. Factors of 4 are 1 and 4, 2 and 2. I want to get 5. The only way I can get 5 would not be with 2 and 2. It would be 1 and 4. Adding them together, 1 plus 4. So this brackets factorizes to x plus 1, x plus 4. But don't forget that there's still the 2 on the outside. So that is it, fully factorized. Next one, fully factorized by removing a common factor. 5 is common across all of them, so put the 5 on the outside. What do I times 5 by to get 5x squared? I times it by x squared. What do I times 5 by to get negative 30x, negative 6x? What do I times 5 by to get negative 80? 80 divided by 5 is, so negative 16. Factorize this brackets with sum and product. 1 and 16, 2 and 8, 4 and 4. The only way I'm going to get negative 6 would be to take 8. So that's the factorization here. In the brackets, it's going to be x plus 2, x take 8. And please don't forget that that 5 was removed as a factor, so that has to stay there. Common factor of 2, put on the outside. How do I get 2x squared? I times 2 by x squared. How do I get negative 2x times by 2? Just negative x. And negative 180 times by 2, I would have to times 90 by negative 90 by 2 to get negative 180, so negative 90. Factors of 90, 1 and 90, 2 and 45, 3 and 30. Does 4 go into it? 90 divided by 4, no. 5, 90 divided by 5. 5 and 18. Uh, 6 and 15. 90 divided by 7, definitely not. 90 divided by 9 is 10. 9 times by 10. Those are the factors. I want to get negative 1 here. Please don't forget there's a 1 there. The only way I'm going to get negative 1 is with 9 take 10. So that's my A and that's my B. So that brackets factorizes to x plus 9, x take 10. And we remove the common factor originally, so the 2 must stay on the outside. This one looks tricky here because suddenly we've got a cubed, but realize that all of these terms have an x in it. Remember here, this last one was a number, so all of these have an x in it. So the common factor is x, that goes on the outside. What do I times by x to get x cubed? X squared. What do I times by x to get negative 7x squared? Well, negative 7. What do I times by x to get negative 8x? Well, negative 8. That leaves us this bracket, which can be factorized with sum and product. So the factors of 8 are 1 and 8, 2 and, not 2 and 6, 2 and 4, and 4 and 2 and 8 and 1. So we stop there. Is there any way that I can get negative 7 with 2 and 4? No, but I can get it with 1 and 8. 1 take 8 is negative 7. So that's my A and B. So this, the brackets will be x plus 1, x take 8, and the common factor on the outside was x. Last set, 4, fully factorize these. So the problem we have in this first one is your rule does not have a negative here. It's positive x squared. So the rule's only going to work when it's positive. So how do we deal with this? There is a number in front of that x squared. For it to exist, it's negative 1. So I can remove negative 1 as a common factor from all of these, put it outside the brackets. What would I have to times negative 1 by to get negative 1x squared? Well, x squared. What would I have to times negative 1 by to get negative 3x? Well, positive 3x. And what do I have to times negative 1 by to get positive 54? Well, negative times by negative gives you a positive, so it has to be negative 54. So now I've removed the common factor of negative 1, which gives me this, which has a positive x squared, which allows me to use sum and product rule as normal on the stuff in the brackets. So you got 1 and 54, 2 and 27. 54 divided by 3. 3 and 18. 54 divided by 4, I don't think. 54 divided by 6. 6 and 9. Is there any way I can get positive 3 with 1 and 54? No. 2 and 27? No. 3 and 18? Yes. 6 and 9. If I go negative 6 plus 9, it's going to be positive 3. So my A and B are negative 6 and 9. So in the brackets, x takes 6, x plus 9. And don't forget that we had the negative 1 as a common factor removed at the front. This one here looks kind of weird, but it's just trying to fool you, putting things out of order. So always put the x squared term at the front. It's negative x squared. That's a positive 4x, and you've got a negative 3. The sum and product rule only works when x squared is a positive, so remove the negative 1 as a common factor. So negative 1 bracket x squared. What do I have to times negative 1 by to get positive 4x? It would be negative 4x. And what do I have to times negative 1 by to get negative 3, positive 3? So I've removed negative 1 as a common factor. This is positive x squared now, so I can factorize with sum and product. 1 and 3 is the only factors of 3. Is there a way that I can get negative 4 here with 1 and 3? Yep, negative 1 and negative 3. So that factorizes to x take 1, x take 3, and negative 1 was the common factor we removed at the front. So this whole set of 4 questions here is just practicing getting you to remove the common factor of negative 1 at the front, because your rule only works for positive x squared. So remove negative 1 as a factor. You've got x squared left over. What do I times negative 1 by to get positive 2x? Negative 2x. Positive 48, negative 48. Factors of 48, 1 and 48, 2 and 24. 3 and 16, 4 and 12, 6 and 8. And I can get negative 2 with 6 and 8. If I go 6, take 8, it'll be negative 2. So that's my A and my B. So that factorizes to x plus 6, x take 8. And the common factor removed at the start was negative 1. Last one here, we're removing negative 1 as a common factor. We can remove negative 2 as a common factor as well. Negative 2, what do I times negative 2 by to get negative 2x squared? Well, x squared. How do I get positive 4x? Multiplying negative 2 to be negative 2x. And positive 126, negative 126. How many 2's go into that? Negative 63. So factors of 63, 1 and 63. 2 doesn't go into it. 3 and 21. 63. 63 divided by 6, 63 divided by 7, 9. So 7 and 9. Is there a way to get negative 2 with 1 and 63? No. 3 and 21? No. 7 and 9? Yes. 7 take 9 is going to give you negative 2. So that's my A and B. So that factorizes to x plus 7, x take 9. And you have the common factor of negative 2, which we removed at the start. There, so that is the hardest factorization you need to do for this topic. And there's plenty of practice there of a bunch of easier ones and a bunch of harder ones. Let's check the answers to this. So this is 2f. F starts here. 3 and 4, yes. C, 2 and 8, yes. E, negative 3 and 12, yes. G, 2 and negative 6. Question 2 is on a separate page. 2a, x plus 1, x plus 2. D, x take 2, x plus 5, x take 2, x plus 5, yep. G, x take 7, all squared. I'd accept this as well, because that means exactly the same thing. J, x take 3, x take 8, yes. M, x plus 7, x take 8, yes. Fully factorized by removing a common factor. 3a, move the answers there. 2x plus 1, x plus 4, yep. What did we ask for next? It was D. 5x plus 2, x take 8, correct. ADG. 2x plus 9, x take 10, yes. J, x plus 1, x take 8, yep. 4, ADGJ again. A, negative. It looks like I stuck this up. Oh no, looking at the wrong one. A, negative x takes 6, x plus 9. You'll notice in the answers here, there's just a negative sign. But that negative sign has a 1 there, which is what I've written. So that's exactly the same. AD, negative 1, x take 1, x take 3, correct. G, negative x take 8, x plus 6. They've got it in a different order. But we've already established the order of multiplication. Doesn't matter. So these can be interchanged as exactly the same. So that's correct. And J, negative 2, x plus 7, x take 9, all correct. So hopefully that helps you out on those exercises. And I'll see you in the next video.